Hi, everybody. In this video, I want to just talk a little bit more about solving equations and talk about a specific or two specific cases of when we get a no solution or when we get something called an identity. So these are your more unusual cases. It's not going to happen every single time, but occasionally we solve an equation and something kind of strange happens. So either we get something called a no solution, which is exactly how it sounds. There's no solution to that equation. Or we get something that is an identity, which is actually the total opposite, in which every real number is actually a solution. And in the real world, that really just doesn't happen. But sometimes algebraically, we do see it occasionally. So it's good to be able to recognize both cases. Now, when you're solving, you may not initially recognize that you're going to have a no solution or an identity. So what you would be doing is you'd be solving as usual, just following your regular solving steps. And then when you get towards the end of the problem, that's when you're going to notice that something different is happening. So when you get to the end of the problem, what's going to happen is the following. So basically, your variable will completely cancel out. And then either you'll have a false statement at the end. So just as an example, maybe you're solving and you get something like 7 is equal to 9, right? Something that doesn't make sense. This is when you have no solution. So there's absolutely no way to get that equation to work out. And then the second thing that can happen is you could have a true statement. So again, let's say you're solving and you get something like 1 equals 1. That right there is when you get what's called an identity. And an identity is when basically all real numbers are solutions. Another way to think of it is that there are infinitely many solutions. So basically everything works. And again, occasionally we do see this algebraically. So you do want to be on the lookout for these two things. In the real world, we really don't see a lot of identities. That would be really unusual. But again, they're still good to recognize and to see what's going on with. So let me do an example here for you to see. Okay. Now, if you look at this, it looks just like a regular problem. So a lot of times they may not be obvious right away that there's going to be an issue with it. So you're going to start solving as usual. Now for this problem, I do see parentheses. So I'm going to start by distributing through and clearing out both sets of parentheses. I would have a negative 2x plus 10. I'm going to bring down the next plus 10. On the right side here, negative 3x, and then I would have a minus 6 and bring down the plus x. I'm going to combine like terms on each side. So on the left side here, I can combine the two 10s to get 20. Now on the right side, I can combine the x's. Negative 3x plus 1x would be negative 2x. So now it's probably looking a little bit strange where you're probably saying, well, I have that negative 2x on both sides. So we're going to keep solving those. So let's say you're not sure, and you would try to get your x's together. And when you try to, let's say, bring the x's to the right, for instance, we would add 2x to both sides. Well, it cancels on both sides. This does not become 1x. It is 0x. So it's just gone. And you're left with, in this case, a 20 equals negative 6. Now, that is definitely false. And in which case, there is no solution to this example. Now, the nice thing too is at the bottom here, let's say you did it in a different order. Let's say you added the 6 first to both sides, or you subtracted the 20 first before you went and added the 2x's. You're still going to get a false statement. It may look a little bit different. So for instance, if I added the 6 to both sides, my false statement would have been 26 equals 0 instead. But in either case, you're still getting that false statement at the end. And here's another one. This one's a little bit more obvious from the beginning. And here again, I can start by distributing. And when I do that, you see pretty quickly that we have the left side and the right side are exactly the same. So if you can recognize that, you would know that you would have an identity because they are perfectly the same. But if you're not sure, you're going to keep solving, right? I would subtract, let's say 3x to both sides to try to get those together. And again, they cancel in both places. So you end up with no x variable at all. And in this case, we have a true statement. Negative 12 is actually equal to negative 12. So something like this would be an identity. So all real numbers would end up being solutions in this case.